Good evening, everyone. My name is Sam Nasser, and this is the Cleveland C# VB.NET user group. A little bit about the group. We meet every month. The meetings are free of charge and open to the public, and we cover a variety of topics related to .NET. You can find all the meeting information posted on meetup.com at the link listed at the bottom of the slide. We'd like to give a big thank you to our sponsors, PostSharp and DevExpress, for sponsoring the post-meeting prizes that will be given away using the eval forms. I would like to thank the .NET Foundation for sponsoring the meetup space, and NIS Technologies for sponsoring the virtual meeting space. Also, I'd like to give a big thank you to Manning.com for giving us a 35% off offer on a selection of books. Whoops, let's start that again. There we go. I'd like to give a big thank you to Manning.com for the 35% off a specific selection of books. If you utilize the URL at the bottom of the slide, along with the discount code MTPCLEC21. And this will all be made available in the chat window later, so you can just simply click on the link as opposed to having to memorize what it is. Some general information. First and foremost, please keep in mind participation is encouraged. And like I always say, the only stupid question is the one not being asked. So always jump in with a question or a comment. However, when not speaking, kindly ask you to mute your microphones just to avoid any background noise. And we like to keep it casual but organized, meaning you don't necessarily have to wait until the presenter stops for questions. Feel free to jump in at any point in time, but at the same time, we want to give our speaker enough time to go through the slides and the demos. Lastly, the presentation is being recorded and will be uploaded on YouTube with a link made available in chat shortly afterwards. So for tonight's feature presentation, we have Heath Murphy discussing home security with .NET Core, Raspberry Pi, and Azure. Heath is an architect, developer, and project manager currently working at CGI. He has 20+ years of experience, and he's been speaking at multiple conferences around the Great Lakes region as well as user groups. And he also has one of my favorite hobbies, racing fast cars. And so with that, welcome, Heath. Glad you could join us. And let me go ahead and make you presenter.
Appreciate your group having me here. I've given this talk a number of times over the years. I originally did a majority of this work in 2020, and then like most projects and hobbies have added little bits and pieces of it over the years to make it what it is today. But it is a home security system, one I built from scratch, and one I actually still use today. I use it quite often. So the picture here is my house, and quick side note here. In addition to fast cars and some other my hobbies I have there, what would you say this lawn is? So if you're looking at this lawn, it's probably, what, an 8 out of 10 maybe? Some may think like a 9 out of 10, depending on the angle you're looking at it. True story, I killed that lawn. I couldn't get from an 8 to a 10 out of 10, so I completely killed that, put Roundup all over it, took it all out, brought in topsoil, and replanted an elite version of a variety of grass, and now I have my 10 out of 10 lawn, so true story. I have too many hobbies. All right, a little bit about me. So I work for CGI, which is an IT consulting firm. We've got about 250 people here in Columbus, but the company's gargantuan. So we're about 93,000 employees globally. We do have an office in Cleveland, and we have, I believe, around 125 people in Cleveland proper. So I'm a director, which means these days I don't get the right code. So that's why I have nights, weekends, and that type of those times to do most of my coding. As I mentioned, I am from Columbus, therefore I think by state law somewhere that I bleed scarlet and gray and have to be an OSU fan. So OH? No IOs at all. There we go. There we go. There's always a few. That's better in person. And true story, that was my COVID hair. You can watch the video and see my hair now, and then you can look at that picture and be, Heath, that's certainly not your hair, but I assure you that is real. It's not fake hair. And yes, before you ask it, it's bleached. So that's how I got the blonde look. But I bet you have a COVID story as well when you look back, 3 years ago what you were doing. So I just let it grow and made a blonde. Other aside funny note here is that when I did that, came in the next day at work, and our admin, who I'd been working with for 8 years, had no idea who I was. I walked in and she thought I was someone visiting from another office. And then I had another lady asked, I thought you had blonde hair. And I told her, yeah, when it gets long enough, about 4 or 5 inches, it just turns blonde. She completely bought it. And last thing about me is I love beer, love pumpkin ales. I have an unhealthy fascination, actually. So I've got a spreadsheet with about 120 different pumpkin ales in it that I've rated over the years. I do more, but I just frankly can't buy them here in Ohio. I've traveled everywhere, and every year there's 1 or 2 distributors that come out with a new one or distribute to Ohio, and I'll find it. And when it's not in season, I'll do any of the dankest Imperial double IPA I can find. And special, just for this event, I don't know if the user group here in Cleveland frowns upon it. Columbus certainly doesn't, but I've got a beer here now. And I chose a beer to represent Cleveland. And hopefully it shows up in the video there if you can see it. But I've got a beer from Masthead Brewing Company there in Cleveland. It's a jalapeno IPA. Delicious. All right, let's jump in. You're not here to learn about me. You're here to learn about what I did here. So again, an exciting project. I'm going to actually start with the end. So I've got a video tour that I created. And yes, it's a couple years old, so it has my blonde hair. And I'll walk you through in my house what I built. So we'll start with the end, go through that, and then come back to the slides. And I've got an architectural overview, how it works. Then we'll cover the hardware things, the software things. And then lastly, I'll actually show you some code, bring it up and show you in Visual Studio. So that's the plan of attack. All right, so the end result. Before I jump into that, let me show you here. So this is my hallway. Open up the front door. This is looking in to the house. And right here on the left is what I'm calling the control panel. So there's a Raspberry Pi tucked behind there with Raspberry Pi, the Adafruit 7-inch touchscreen on top of it. And the actual user interface there, which we'll cover, is a Vue.js application running with backed by a .NET application.
So do you have the power cable running behind it, behind the wall?
Hold that thought, because it gets worse, Sam. It gets way worse.
Fair enough.
The quick answer is yes.
Okay.
All right, so I'm going to play this. Let me know if you don't hear audio coming from this. I may have to make sure audio comes through to the presentation here, but let's see if you can get audio. Oops, gotta press the play button.
Nope.
Yes to audio or no to audio?
No to audio.
Okay.
The video is very choppy in the movement.
Yeah, of course I'd have issue with audio, and I don't know if there's an option to even give an audio in the video here. I'll tell you what I can do. How about I just give you narration? So I'll narrate me from 3 years ago. Let's do that. All right, so essentially what I'm doing is describing that, hey, this is real, I use this, and it's not something that I'm just making up here and I wrote code for. So we're heading down to my basement, and inside the basement, of course, is where you'd expect to find my control panel. Now, this is an ADT system. So ADT, the prior owner paid ADT $50 a month to come in and install the system and then monitor it monthly. Now, when I bought the home back in 2017, the owner wanted me to take over that contract. I said, no thanks. Knowing that eventually one day I would come back in and build this. So the home was already wired, and what you're looking at here is the finished product. So this is, as I have it today, I've taken all of their wires, reverse engineered, which I'll go into detail. I've got a few slides here, and I've connected that to the Raspberry Pi, which you see right in the middle there. And there's a few other devices there that we'll cover, sitting down at the bottom. The terminals, you can see 2 of them there at the bottom right, and then the big one going up the left side. Those are terminals, 3.3 volts on the left, and then a 12 volt and ground on the right-hand side. So those are essentially what I've got most of the wires connected to. And you can see it's a big rat's nest of wires. Everything is hardwired, which is good. Much better than the wireless sensors. And this is kind of where it is today. And I've cleaned it up, so no judging. It's a little bit better than that today. This is 3 years ago, but this is essentially where we've landed. Now, what I'm showing here is that extension cable going all the way across the top there. Yeah, there's a funny story about that. And you asked, how did I wire up that Raspberry Pi that I showed you on the wall there? I wired it up right here, actually, by running this extension cord and plug it in there. And then you can see how I've sliced it in with that white wire. That goes up to the top. And I've got a slide where I'll show you some power woes and if you take on a project like this and things you might run into. So that's what I'm describing here is how I had to get power to that unit. Good news is you can't see it. It's on the back side of that beam and no one would ever know it's there if you weren't the wiser. These are the smoke detectors. So the home came with smoke detectors. By code, the builder had to add them. ADT added 2 additional ones so that they can monitor them with their system. And both of them are right down there where they need to be near the HVAC system. I do have that wired up and connected. And that right there is a jank job. I spliced in a outlet so that I could power my cameras outside. And I'll show you when we get up here. All right, what I'm showing here is magnetic sensors. So this is an example of a window magnetic sensor. You can see the bottom part where it's wired up. And then the top part, I'll go into a little more detail, has a magnet in it. You're about to see my wife jump out of the video because she didn't realize I was coming in making a video that potentially thousands of people would see. All right. Hard to see in the video here. I've got a picture of it, but this is the same magnetic sensor, but one for the doors. It's built a little bit different form factor. And on the patio. So that's it. What you saw downstairs where I put in, spliced in, that was speaker cable. Sometimes when you take on a project like this, you got to be creative. I wanted a camera there. I didn't want to run wiring up to be able to power that. So there was speaker wire. It was like heavy duty 16 gauge, 14 gauge wire. Plugged it up thinking this might not work. It's a big long run. And sure enough, it worked just fine. I was able to power that camera and give it 12 volts I needed. So winner, winner. And there's a close-up view of the application or the control panel. And there's a moment where I like to just take pride in what I did. So it looks nice, doesn't it? Really happy with how that came out. Now my wallet's not really happy with how it came out because, oh, side note, there's me showing off my cars. I didn't realize I was doing that, but I've given this talk at enough conferences where people will come out and say, you're just showing off your cars. And I'm, yeah, okay, maybe. So this is showing it in operation. So the garage door obviously is open. Garage door closed. Stop showing off, Heath. And there you go. And at this point in the video, I'm not sure what I'm talking about, but it's probably important. Okay, arming the system. True story, I thought this is going to be a great idea. I'll build this and there'll be a button right there. So as I walk out this front door, I'll click that and arm the system. That way it'll always be armed and it'll notify me if someone tries to break into the house. In reality, what happened is no one ever touches that button. No one ever arms this. This is where we fast forward to where I am now in 2023. I started with this, built this, and now I've implemented Home Assistant. If you're familiar with Home Assistant, it's does a lot of things, but it's a platform for home automation. And I've actually have Home Assistant attached to this, and by attached meaning I have automations that call web API that I built in .NET that allows Home Assistant to automatically arm and disarm the system based on if we're home or not home. So I've taken it to the next level. And then like I was telling Sam earlier, once you get into a project like this, you just it takes on a form of its own. You start creating new automations and getting new sensors and getting new hardware. It's certainly fun. You learn a lot. But when you have a lot of automation, you think it's going to make your life easier, and it does. It really does. It helps. But also, there's always something that doesn't work. So no matter what you're doing, there's a little sensor or a little part of the system that doesn't quite work right. So on the other hand, it kind of complicates your life a bit. All right, I'm going to go ahead and stop it here. I think you've got the gist. So I'll pause there real quick. Any questions before I jump into the presentation? All right, no questions. So we will move on. Okay, so let's start with the architecture. I am an architect by trade, but again, as I mentioned, these days I don't get to write much code. So this is where I get to show off some of it. So I always like to think, I typically like to think top down. So that we'll start top down, and then I'll show you the code. True story here. So all these images all have some backstory to them. This is an area, it's in my attic, pretty obvious to tell from this, but this is right above my front door. So you walk into the front door of my house, there's a camera right above the front door. And the camera was installed there by ADT, really old camera from like 2012. Wasn't 1080p, wasn't something I was going to need, but conveniently it was wired up. So it was a good place for a camera. So I knew I was going to buy this nice 1080p or 4K camera, install it there, and just leverage the existing wiring. And there were a couple areas where they had cameras that I could wire up. So this one, installed the camera up there and had my new wire, and obviously the wire to the new camera didn't exactly match the same plug of the old one, so I had to splice it and made a shocking discovery. The wire was live. And come to find out, I couldn't figure out why it was live because all the other wires in the basement were completely disconnected. And that's when I found this. So there's a little crawl space where you walk in, and ADT, when they installed this, said, yeah, let's put an outlet right there. That seems convenient. So let's just say it was a shocking discovery. Okay. And sorry, my dog is in the background barking. Okay. All right. So let's start here. Again, architecture, big picture. There's three different components to this is the way I've got it set up here. So down at the bottom, we've got what I call the sensor monitor. So Raspberry Pi down in the basement, what you saw connected up to all those wires. Its job in life, its main primary goal in life is to sense things. So you see windows, doors, cameras, you name it, it's sensing those devices. Not making sense of them, not doing extra processing, do some sensing, and then pass that up to the second layer, which is the control panel. So control panel, which you also saw up near the garage door, is a Raspberry Pi with a screen on top of it. The application you've seen, which I mentioned already, is just a Vue.js application. And again, I'll take pride in this, hand wrote, created the design myself and have it out there. So it's a .NET process that starts when Raspberry Pi, Raspbian starts up, launches the Chrome browser, and then just goes to the localhost URL. That's all you're looking at here. And the communication back and forth is using SignalR. And on the control panel side, there on that Raspberry Pi is a SQLite database. And then lastly, the third part of it is what I call the cloud dashboard. That's hosted in Azure as a true SQL Server database, because that's what you do when you're a .NET Microsoft developer. You put things in SQL Server. And there's an accompanying app that I have that's also a Vue.js application where I can see remotely from anywhere in the world, the status, ARM status, if there's an alarm going off, and it's connected up for push notifications. So depending on the circumstance, I can get a push notification like any other push you see on your phone come to my device. So question of the group, why do you think I have this? I have a SQLite database here in my house, in that control panel, but I also have a SQL Server database up here in the cloud. Why do you think I need this? No dumb answers.
What, loss of connectivity to the cloud maybe, or? I'm imagining the SQLite is more configuration.
You hit it. It was the first thing you said. That's exactly right. I want my system to like work, even if I don't have connectivity to the internet, or if I don't have my Azure. We're developers, we write bugs. So if I create something and my Azure application crashes, I still want it to work locally. So that's exactly right. So this will store all the interesting events, doors opening, closing, whatever I need to track locally, and then leverages eventual consistency to say, eventually I'm going to connect and be able to push this data up. So it'll purge anything in there after it does a sync up. So it's exactly right. All right, there is a lot going on here. And again, as an architect, I try to complicate a lot of things, but I promise you we'll walk through this and hopefully it will make sense. And then I'll give you the reason why it's so complicated. But basically the three levels that we talked about: sensor monitor, control panel, cloud dashboard, and blue and red. Blue are things going up through all the different layers, ultimately out to my phone. Red are commands coming down to either the controller here or to the control panel itself. And commands, as you can see here, I have the ability to arm the system. So I can arm it from my phone, or automated through Home Assistant, and I can turn on the siren directly from my phone. But let's pick this apart piece by piece and kind of explain how it's all put together. So we'll start with the sensor monitor. And every part of the architecture here should own something. So its goal in life is to own sensing things, and then also own the status of the alarm. So the alarm here is and I've got a picture of it, is an alarm that the ADT installs. And the idea is someone's breaking into your house, they can remotely cause the siren to go off, or maybe just automatically goes off. Has anyone ever heard one of those home alarm sirens?
Oh, yeah.
This is not like your car siren. This thing is so loud. I got a funny story about that, where people in the house were running like crazy. It's really loud. So when I designed this, I thought to myself, well, if the system's armed and someone opens the front door, I bet someone's breaking into my house. Probably not true. It's likely my 19-year-old son. But that's at the point, 3 years ago, me thought that. So I'll just make it to automatically turn on the siren. Don't do that. So now I have a way to look at my cameras and then make a decision if I want to actually turn the siren on or not. Okay, this thing has a GPIO controller, which does all the magic. I'll show you the code here at the end. The code is really simple. Actually, you'll be surprised at how few amount of C# lines of code I have to be able to make all this work. It's magic. It's going to make you so happy, actually. You're going to go out and buy a Raspberry Pi, if you could afford one or find one today, and go out and do this yourself. Truly was that simple and that easy. But we've got a GPIO controller with I/O pins. I've got a process that wakes up every 2 seconds, reads the state of the world. Give me the state. Read all the sensors, all 20 sensors. Open, close. Is it smoke detecting smoke? Is the motion sensor detecting motion? And then takes that through a SignalR connection and shoves it up to the control panel. That's all it does. Really simple. It's stateless, and completely headless. There is no user interface. Fun fact, you'll see I put Ubuntu 19.1. When I originally wrote this back in 2020, Ubuntu supported 64-bit, which at the time .NET Core 3.1 was a match made in heaven. That was the first version. The 64-bit ARM64 ran on Ubuntu. Didn't run on Raspberry. So I chose Ubuntu, and it worked fine. My problem was it had very heavy. It's a very heavyweight operating system. Even the one that's built for Raspberry Pi, to me, was just way too heavy. Since then, .NET now supports Raspbian. So I moved over to Raspbian probably 2 years ago, and I've never looked back. And I recommend you do that. If you're doing .NET Core or .NET anything on a Raspberry Pi, just use Raspbian. No issues. Okay, then we get to the control panel. So following blue lines up, I've got a SignalR hub here that accepts the incoming state of the world and shoves it into a SQLite database. As simple as that. A couple different processes. I've got what I call a cloud dashboard sync, wakes up every 2 seconds and takes all those changes, the deltas, and pushes them up to a SignalR connection to Azure, if it has connectivity. That's the important part. If not, it just leaves it there and goes back to sleep and waits for the next 2 seconds. So if you're doing your math, within 2 seconds out here on the control panel, you'll see that I've got an update. So if you saw it in the video there, it was probably subtle, but when I opened a door, closed the door, within 2 seconds it shows up. I call that near real time. Actually, in fact, I call that real enough time for me to say, okay, it's real time. And within potentially 4 seconds, I'll see it on my phone. Worst case. So that's quick enough for me. I could have made it 1 second, but 1 second just felt weird because I'm an even guy and not an odd guy. Done. But 2 seconds it is. I also have a process here that kicks up and runs every 30 seconds and checks what I call system statuses. And that's basically like Wi-Fi connectivity, the connectivity to basically all the green things that show up here. And does the same thing, reports those out and reports them to the database. Okay, I think we've covered most of this. It is stateful but fault tolerant. When an application starts up, it completely rebuilds the SQLite database from scratch using EF core code first. So it can handle and will handle, if you take on a project like this, the SD card completely crashing. What you'll find is about every year and a half, you'll be out buying a new SD card, hopefully taking and replacing with one you did a backup on. Do backups, extremely important. All right, and then lastly, the cloud dashboard, SignalR. Again, this one is secure because we're in the cloud. Who knows who has our data? So it is a secured connection. SQL Server, and then really all the smarts are here. When I built this, I knew the smarts would be up here in the cloud somewhere. So this thing wakes up and then looks at the state of the world and determines, is this something I need to notify Heath about? Is the alarm set, or is the system armed and the front door is opening? Okay, let's notify Heath. The system's not armed, but the smoke detector is going off. Should I notify Heath? Yeah, I want to be notified. The smoke detector is going on. So the smarts are really here. And again, that all goes through a SignalR connection pushed out to the application in near real time. And then the commands, I won't go back through them, but the commands are all essentially the same, using SignalR pushed all the way back down through, in some cases, all the way to the Raspberry Pi sitting in the basement to turn on the siren. Okay, and I think we've covered most of that. Security is just the typical JWT token standard fare. All right, we covered a lot here. And why this architecture? Why that complicated, Heath? I could have done some of that with having fewer layers. And well, I always use this quote because I'm an architect that works for consulting companies. Therefore, I need to maximize complexity wherever possible. A joke, but there were some goals I wanted to achieve here. One is we already talked about the system needs to operate even without a cloud service. So if Azure goes down, I still have a security system. Does it do me a whole lot of good if I can't access it with my phone and I'm not there? Probably not, but somehow I feel better about it. As you saw, SignalR is being used everywhere. So it's fast, it's lightweight. You've got bidirectional connections. If you're not using SignalR, and this is probably more prevalent in 2020 when, before Blazor was really embracing SignalR, but if you're not using SignalR today, that's another takeaway from this talk. Even if you don't do any of the home automation stuff, use SignalR. It's really awesome and has a lot of applications that I don't think are being used in a lot of companies. Another goal I wanted here is no inbound connections. Now I can go into my router and set up port forwarding and allow things to be to inbound connections to my network, and I do that in a few areas, but for this I wanted it to be an outbound connection. SignalR allows me to do that. From the control panel, I can make a SignalR connection that's outbound. Now once you create that HTTP SignalR connection, the WebSocket. From then on, it's bidirectional, but it's all outbound and not inbound. And then lastly, separation concerns. So you'll have things that break, SD cards that go bad. It's just easier to do deployments when it's broken up into 3 different areas. Okay. And we already covered this. And yes, when I installed this, yeah, I boogered that up a little bit, but hey, it's in a basement. No one ever sees this. All right, so let's jump into the hardware things. Probably what you came for this talk about. So I know this is a .NET user group, developer, software. You do a lot of that. You probably do a little bit less of the hardware things. So we're going to jump right in. Here are just some pictures of what ADT left behind. And this picture still doesn't know justice. I call this the rat's nest, but at this point, you see all my little twisties on there. I've gone through and have somewhat cleaned it up. It was just a gigantic mess of wires everywhere. This is a motion sensor. If you've never seen one before, now you'll see these things everywhere because they are everywhere. Obviously a camera, and right above here was the shocking discovery. This is the siren. The picture makes it look a little bit bigger than it is. It's actually pretty small, about the size of a postage card. But the sound of a big dump truck, it's really loud, only way high pitched. And then I already covered this. This is a magnetic sensor. So the way these things work, they're really cheap. You can get them for like pennies. There's 2 wires coming in, and there's a switch inside here. So the magnet up here. When the magnet's down here, the switch is closed. When you move the magnet away from it, the switch opens up. So it's as simple as that. It uses the magnet to open and close that switch. Okay, and here is the list. So 13 magnetic sensors, the 3 door sensors, a motion sensor, very loud alarm siren, and the smoke detectors. There were 2 of them, one in the basement, which you saw, and then one upstairs in the center portion of my house. Then, of course, the camera we talked about. It came with 1. I now have 4. And so another question that you asked is, how is this thing wired up? I'll go into a little more detail, but right here was the ADT panel. And I knew this because when the homeowner left the house, he took it off the panel off and sent it back to ADT, or maybe took it with him. I'm not sure how that all worked out, but he did a pretty bad job of plastering the hole there. So I knew it was back there. I did a pretty good job of opening the ADT hole and making it gigantic. So the next homeowner that comes in, if they don't want this system in there or don't want that, they've got a giant 4-gang box hole in the wall here that needs to be plastered. But when it's all put together and connected on the wall, it does look pretty nice, I think. I'm happy with the results. All right, so here's another example of the magnetic sensors. This is the one on the door. This is the magnet. So what they do is they bore out a little hole, little circular hole, and then just stick a magnet in there. I assume there's some adhesive or something that keeps it inside the hole, or maybe it has a little screw on the back side of it, but that's the magnet. And here is the sensor. So this, or not the sensor, the switch. And back behind there, if you were to pull this out, there are 2 wires connected to it to go down to my basement. So that's, if you're wondering how they do it with a door, this is how they do it. And as I mentioned, the 2 wires are basically shorted, so it's closed when the magnet is there. So step 1, when I took on this project, was, okay, I know the lay of the land, I know kind of what I want to build, and I've got a mess of wires here. So I need to go through, you saw I had 26 window sensors or something like that. I need to go through and figure out all these wires. Okay, I've got 2 wires. Which window does it go to? And as you can imagine, ADT didn't want their system to be reverse engineered, so there wasn't an obvious sticker that said, oh, this goes to the kitchen window, this goes to the bedroom window. None of that existed. So what I had to do was take 2 wires, take the 2 wires, connect them up to my ohm meter, and then have my wife and son go throughout the entire house and open up every window. Nope, not that one, not that one, not that one. Eventually I'd see where the circuit opened up, and I knew that was it. So reverse engineering every single one of these, and then I've got a numbering system. So all these numbers are in an Excel spreadsheet that says this number 11 maps to this window or this door. So reverse engineering, it was fun. But no, it wasn't really all that fun. It was a lot of work. All right, we're going to get into our first circuit diagram, and these circuit diagrams are really, really simple. Nothing complicated about them, but we'll jump in here with it, actually the simplest one. So if you've not worked with a Raspberry Pi, this is the pinout. And it's been the same pinout for, I think, all the versions of the Raspberry Pi, including the current version. So you'll see some are power, but the important ones here are the GPIO. So you see where it says 14, 15, 18, 23. These are the general purpose IO pins that you have available to you to use as an input, as an output. You have multiple uses for them. And through code, you can connect them up and say, I want to use GPIO pin 27, for instance. And I'll show you in code how that works. But what we wanted to create here is a way to detect when this magnetic sensor opened or closed. Really simple to do with GPIO pins. So how I wired it up was this. Imagine the sensor over here is this switch. And so we put 3.3 volts coming out of the Raspberry Pi. The Raspberry Pi makes 3.3 volts. You feed it 5 to power the Raspberry Pi, and it outputs 3.3. 3.3 volts go down, and then any one of the GPIO pins, you pick it, you set that up as an input pin, and then read that. And then through code, you can tell the switch is opened or closed based on the status of the pin, whether it's high or low. Now, a couple things. Internally, a lot of people, when they build this, they put this resistor, it's called a pull-down resistor, on the outside. I recommend you do that. Actually, what I recommend you do is completely isolate these wires from the Raspberry Pi. And the reason I recommend that is because about every year, I need to go down and replace, or not replace, reconfigure my Raspberry Pi. And I have these wires, and this diagram, these wires are what, a couple inches apart. In reality, what happens is that Raspberry Pi is in the basement, and these wires are 100, 150 feet long because they go all the way up to my son's bedroom, which I think is the furthest point from where the Raspberry Pi is in the basement, to his window. And when you got a wire that's that long, it becomes any sort of static that can hit that thing. It becomes a absorption for any sort of interference, and you get a jolt of high voltage that just blows this resistor up. So it's kind of humorous at this point in time is that when it happens, I know it happens because no matter what the switch does, if I open or close the window, that code never sees this change. It's either opened or closed, and I forget the exact status of what happens when it blows up. So what I do is find out, okay, so I've used 25, but I haven't used 14 yet. So let's change the .NET code until I can find a GPIO pin that I haven't blown up yet. So yeah, I recommend you don't use the internal pull-down resistors and instead use something to isolate it. So lessons learned.
Question, Heath.
Yep.
Would it be useful if you used a shielded wire for those two external wires?
Probably, yeah. At this point, I mean, it certainly couldn't hurt. The wires are just raw copper wires. They're in there, so shielded might help. Okay, so this is by far the simplest circuit diagram. It gets a little more complicated from here, but I promise nothing too difficult. So the next thing is the motion sensor. So awesome. I opened up looked at the wires going to the motion sensor, and I have 4 wires. And that's important because the motion sensor itself has electronics in there. All the LED that shows up and the electronics to do the sensing of motion requires 12 volts just to power it up. And I had 12 volts. So I took 12 volts, took 2 of those wires, powered it up, we're good to go. The other 2 wires were stupid simple to wire up because it was the same type of switch. So it was open close. And depending on if it's sensing motion or not sensing motion, this switch will open up or close. So it was really easy for me to take that, wire it up in the same fashion that I did the Windows to be able to access that in .NET code. So this was also an easy one. Then we get a little more difficult. So I had the dilemma I had here was I've got a siren, and the siren is just 2 wires going to it, and those 2 wires are 12 volts. And you give it 12 volts, it makes a really loud noise. You don't give it 12 volts, it doesn't make noise. It's as simple as that. So I needed to give that thing 12 volts. The problem is I can't do that with the Raspberry Pi because the Raspberry Pi doesn't talk 12 volts. The Raspberry Pi talks 3.3 volts. That's the logic it talks. And even if I could, I can't power a siren with the output, the GPIO pins of a Raspberry Pi. It's made for logic and not powering things. I needed something called a opto-isolator, optocoupler. In more layman terms, you probably heard it as just a relay. I needed a relay. And so I found one on Amazon that was pretty cheap. They come in like 10 packs. Now when you buy them, you tell it what TTL logic you have. The Raspberry Pi talks 3.3 volts, not 5 volts. But how it works is you give, you wire up the 12 volts to the siren, and the switch is on this side of the relay. So I want to operate this switch, turn it on or off. But I want to operate the switch using 3.3 volts that come out of the Raspberry Pi. So the wiring was pretty simple, and then just feed the device here, the optocoupler, 5 volts to power itself. And then I used a GPIO pin and set it to an output so that I could send the command to say high or low, which turns this on or off. So pretty simple device. If you do any sort of home automation, you'll use these things everywhere. They're essentially switches that you can control with your Raspberry Pi. All right, and then we get to the most complex one. And there'll always be something. You'll get in a project like this, and the 80-20 rule, you've got 80% of it done, and it's up, and that last 20% you spend a lot of time on. And I did. And the issue I had here is I had those 2 smoke detectors, one in the basement and then one up here in the attic. And I wanted to be able to connect those up, but when I looked at it, I only had two wires. The 2 wires were for 12 volts. The 12 volts powered it. So I'm like, if I'm powering it for 12 volts, how do I detect when this thing is going off or not going off? Because that's ultimately what I want to do, is detect when it's going off and send an alert to my phone. So I found, did some research, looked up the model number, did some Googling, as a good developer would, found this board. Okay, there's a board the ADT has, and you wire it up, and really, actually, it was probably an overcomplicated board. There was a lot of devices on the board used. I found it used on eBay for $225. So I'm thinking, I don't know if I'm committed this much. $225, it's used, it's on eBay. The thing might not even work. Even if it did work, the ability of me to reverse engineer this complicated board to get it to do what I need to do, slim to none. So I had to think to myself, okay, how else would I do this? And then it hit me. I forget, I think I was probably driving somewhere at the time, driving too fast probably. And I thought, when you power up a smoke detector, give it 12 volts, what happens? Well, there's a little LED, if you look at them, that's on, that's probably red or green, I forget what color it is. And it's sensing for smoke. That's what it does. What is it not doing? Any thoughts?
It's not making noise.
That's right. Yeah, not making noise. Okay, that's something. So if I go with that, let's put an ohm meter on it and measure the current, how much current draw it's taking when it's just sitting there doing nothing. And so I did that, and it was using about 8 milliamps of current. Okay, that's fine. Then I went up and pressed the test button to make noise. Then I went back and tried the current. It went up to like 35 milliamps. That, again, small number of milliamps, but the order of magnitude from 8 to 35, that was the key. I can detect that. So I can detect when there's a big draw of current, and then my logic would be, if I just sense a big draw of current, then hey, this thing's probably making noise. If not, it's probably not making noise, and that was good enough for me. So I knew what I needed to do. and then I had to do some research on how to do that. So here's where we get into an ADT circuit, so analog to digital conversion circuit. INA 219, if you look at that, is a chip. Actually, this is the one I bought. And I bought this super cheap from Micro Center here in Columbus. Not even made for the Raspberry Pi. You can see this is made for like a featherweight, feather wing. It's completely not what I need, or not the same form factor, but it worked. So I was able to wire this up and had to give it power, had to give it ground to power the chip itself. And you basically connect up your 12 volts and then run it through this. So inside here, the chip is basically doing that sensing for me. It'll tell me what the voltage is across these pins. It'll tell me what the current is, a few other things it'll tell me. And then you connect it to the Raspberry Pi using the I2C interface. It's a hardware communication interface, and it's been around for a long time, very long time. So there's a lot of good documentation, and I found a good library on NuGet that allowed me to connect to that. So it was as simple as that. So I built this, and again, spent way too much time thinking through how I had solved this, and the code to actually solve it was fairly trivial once I got it up and running, and it works. That is me testing. So with any of these projects, you're going to have all kinds of test leads and wires connected, and hopefully you don't blow something up, but sometimes it happens. Be prepared. Featherwing, it is. I can see it right there. INA 219 Featherwing. And I showed you this, the end result. Yeah, works for me. Somehow I decided I wanted to put my switch in there as well. I don't know why, but it looks nice when you close the door. You can't see anything. And the control panel. The form factor here, so that this outside edge is actually metal, not plastic. I think I paid about 150, maybe 120 on Amazon, way overpaid for it. I think it was a custom build. Some guy had built these and we're selling them, but it actually turned out really nice. If you look at it, it looks professional. People would think I have an ADT system there because of the form factor. So I'd say splurge on those things. Yeah, it was expensive, but I think the end product is way better than if I had some janky piece of plastic up on the wall. All right, promise I'd come back to these power woes and why I had to do this. So in the video I showed you this. There's the power cable. So let's go backwards here and where I started. So this wire here, actually I spliced it, I cut into it, but it goes all the way. I know you're not seeing my head as I twist, but this goes all the way back over to the box, the control panel box, or not the control panel box, but the Raspberry Pi box. And as you can see, I had 4 wires. 4 wires, ADT was probably using 2 of these for power and 2 of these for some sort of communication to their control panel that was setting up here before. I didn't want to run new wires. I wanted to use these wires. They were already there. They work fine. So I've got a red one. I've got a black one. Raspberry Pi takes 5 volts. Okay, then I'll just plug it into 5 volts and see what happens. Did that. The thing wouldn't even turn on. So connected to 5 volts. Everything was there. I can measure it. I'm getting 5 volts. Nope, wouldn't turn on. And I'm thinking to myself, you can even tell from the image here, they're really tiny, skinny wires. So I'm like, okay, I can solve this. If I've got 4 wires, let's just connect them up. Now I have 2 really skinny wires put together, twisted together. That makes a slightly bigger skinny wire. So I did this, and I booted up. I'm thinking, okay, we're good here. We're good here. I get past the, at the time, Ubuntu screen, and I get to the home screen, and then I see this weird thing. Like, it's not part of Ubuntu. I didn't write this on, as any part of my Vue.js website. It's a lightning bolt. Anyone on here doing much with a Raspberry Pi? I've seen the lightning bolt.
This conference will now be recorded.
Yeah, so
Sorry, hit the wrong button.
No problem. Yeah. So it's the lightning bolt of death, I think. So I had to do some Googling and figure out, okay, what is this lightning bolt? That's basically the Raspberry Pi warning you. It's like, okay, I'm warning you right now, Heath. I'm powered right now, but don't trust me, because at any point in time, if something loads up or I get an application or some process starts in the background that draws too much current, I'm shutting down, and I promise you I will. So lightning bolt of death is nothing you want to mess with. So then I had to come back over here, run this janky wire over here, move the power source closer so they don't have as much voltage drop and current loss across such small wires. I still had to do the 2-wire trick, but from down here, the lightning bolt went away. Life was good. So long answer back, Sam, to your original question about how's this thing powered up. This is how I had to do it, and it works. Okay, why Raspberry Pi, C# and Ubuntu. Yeah, this is Raspbian now. Again, it's from 3 years ago, but I like C#. I like all the things .NET. To me, it's just much easier. All right, before I jump into the software, I'll pause here. Any questions on any of the hardware stuff I've covered?
The only question I had was, can you hear that siren down the block, like down the street, or is it just inside your house?
Oh no, you can hear it outside.
Oh, good. Okay, cool. So the neighbors can hear it too. Right on.
Yeah, it's loud. And it's such a small device too. I think it's just the frequency of the sound itself is just irritating. I don't even know what it makes you want to hold your ears.
So that alone might,
I'm sorry, go ahead, James.
I was just going to say that alone might cause the burglar to get the heck out of there.
It's going to cause attention for sure.
Yeah.
What if you wanted to add like a strobe light on the exterior of the home to draw more attention? How would you do that as far as electrical draw?
Yeah, that'd be piece of cake actually. So the example I showed there with the relay, it'd be very similar to that. So I'd have I'd connect up a GPIO pin to a relay, and I even have a few of them sitting down in the basement, and then wire that up to the strobe light's probably going to be just wall voltage, so 120 volts. They make them that can connect up to, actually the one I have can go up to 300 volts, I think, and just turn on a strobe light or any sort of light.
Okay, thanks.
Yeah, but it's awesome though. That's a great idea, and then you start thinking of more ideas, and then more ideas. Before you know it, you've got your whole house is like all automated. It's fun. I love it. Okay, let's jump into the software. All right, again, being an architect, I get to show you architectural diagrams. But so here, I don't know if you're familiar with onion architecture, sometimes called hexagonal. It's been around for a while. We use it a lot at CGI. Had a lot of luck with it. It's just a way of structuring your code. So of course, everything I've built here is onion. It doesn't need to be an onion architecture, but that's just what I know and what I've done. So looking at the sensor monitor stack, the drivers are all pre-installed. Nothing special I needed to do there. Ubuntu, but we know it's now Raspbian. I've upgraded it to the latest and greatest .NET. Still runs like a beast, no issues. Even the NuGet packages, after all these years, I didn't have to go back and change code and break things, which is relieving because I thought all this was going to break if I did any sort of .NET upgrade, but it all worked. The magic is in NuGet packages, so system to device GPIO and IoT device bindings. This is what does all the magic for me. And then SignalR is just SignalR. True story. When I say this, any ideas? So GPIO pin state outlives your code. Any ideas what that means? Okay, so let me paint the picture here. I'll kind of just imagine you're me up here at my desk, which I think you can see the video here where I am. So I got a nice desk, and it's a lazy Saturday morning back in 2020. No one's leaving their home, so I'm here. Probably have coffee, and I'm working on this code. And I have everything mostly wired up, and I'm remote debugging up here for some reason. Who knows why? And I'm testing the siren, and I warn everyone. So I warn my wife and warn my son that I'm testing the siren. I'm gonna run this, and the siren's gonna go off, but don't worry, because I'll turn it off. It's just gonna go on just for like a second or two. I want to make sure this code works. So I run the code. Of course, there's a bug. It didn't quite work exactly how I wanted to. I missed an if statement or something. Who knows? The thing goes off, and then doesn't stop. And I'm like, it's loud, it's crazy. So I'm like, okay, I can solve this. I'll just stop Visual Studio. There's a stop button there. If I click stop, this thing will stop debugging and no issue, no harm, no foul. Yeah, that doesn't work. You hit stop, your process stops, but your code, the GPIO pin state is not driven by your code. That process doesn't have to be living, holding that pin open. Once you tell the hardware to open or close that pin, in this case, I told it to open so I could, or actually close to make the siren go off, it's there. So I'm here upstairs, it's loud. The cat is running everywhere. I think I actually stepped on the cat as I was trying to run down 4 flights of stairs to get to the basement. To unplug the 12 volts going to the siren so I could turn the thing off. So that's the exclamation here, is that when you do something like this, just your process doesn't drive the hardware. The hardware is the hardware. Okay, the control panel stack, very similar to what you saw before. Nothing I need to do with hardware. Using the SQLite Entity Framework code first migrations. All this, if you've not done anything on .NET and Linux and SQLite and Entity Framework code first, it's magic. It just works, just like as you expect with SQL Server, just as easy on Linux using SQLite. Highly recommend it. I think all the rest is just standard fare here. I am using the SPA services to serve up the Vue application that's contained within the deployment. So I publish my .NET app, and then I publish my Vue application, do a Vue build directly into the www folder, and then publish that using .NET Core, and then get that, or move that, FTP that up to the Raspberry Pi for deployments. Okay, don't be this guy. Okay, there's something on there. What is that? There's a little message there. What is that? Ah, it's an updated version. Okay, seems fine to me. It's probably fixing a bug or some security flaw. So I'll click the button. Be careful when you take a project on like this, especially with at the time Ubuntu supporting ARM64, .NET supporting ARM64. I clicked that little install now after things were running. The whole system did not reboot. It did not work. .NET did not work. Nothing worked. And I had to go back and get an older version of Ubuntu to get things installed. So this is my point here, is that when you take on a project like this, be careful about updating software and what it's going to do. Have a backup. That way you're ready for it. Okay, cloud dashboard. Nothing super new or interesting here, I think. All the same stuff as what you saw before, so we'll skip over most of this. And yeah, it's Azure, as you'd expect. Good old Azure, nothing fancy about it. All right, you guys want to see some code?
Let's do it.
I take the silence as a resounding yes.
Looking for the mute button.
All right, let's go do some code here. I think you'll be maybe a little unimpressed with how little bit of code it is. But I've got a demo here. This is, as it looks like a form factor of a phone, is, as you imagine, my phone application running in debug mode. And this is the control panel. Let me jump through the code and then I'll show the demo first. Does the code look okay on your screen? Do I need to zoom in a bit more?
Oh, it looks good.
Perfect, okay. This is it. Before I talk through the code, I've got a class here, security monitor service. I'm gonna scroll so you can see, run through code, some methods here, and some boilerplate, and we get down to 137. That's it. This is all the code it took for me to interact with the hardware. Now, there's lots of other code that does the connectivity, the SignalR, all that. I don't bore you with any of that code, but when it comes to just code that interacts with hardware, this is it. And this is not me pulling smoke and mirrors. I'll open up all these files. There's nothing in any of these other files that have anything to do with hardware. It's just this, which is the magic of all this. And you can see a lot of this is just boilerplate. So let me walk you through it and just show you how easy it is to interact with the GPIO pins. So with this, I've created a dictionary here, And the dictionary are basically everything I want to monitor, all the sensors in my house. And these are the actual pins. So that pinout I showed you of the Raspberry Pi, where you have GPIO 1 and 22 and 23, that's these numbers. So basically I've mapped loft window to GPIO pin 22. So simple enough. I've created this dictionary. I'm going to use this later. And I've got an initialize method. So the initialize gets called, as you can imagine, when things are booting up and we're getting everything ready to start polling every 2 seconds. So we're not in the poll stage, we're just initializing. And this is the NuGet package for the GPIO controller. So new it up, and I go through that list of key value pairs in that dictionary up there and just say open pin. So I want this to be a pin mode input pull down, because I'm doing a pull down based on the circuit diagram I showed before, with the pull down resistor on the inside. So I want a pull down pin, input pull down, and then give it a pin number. So I just go through all that, and then that's done. Now all my GPIO pins are initialized for the windows, doors, all those types of sensors. And here we've got some code that's working with the alarm siren. And you can tell with my comment here that I got a little scared and wanted to make sure, okay, this thing's better be low. So in my initialization here, I open the pin, set it to an output, because in this case, I want to turn on the siren. I want to output voltage to that relay to turn it on and off, and then immediately turn it off just in case, because you never know. And then looks like complicated code. It's really not. On the GitHub site that I use for the INA 219, it was basically a bolt-in plugin that I was able to bring in from a NuGet package. Had all this documentation there. So this is basically setting up that INA 219. The numbers aren't super important, but this initializes it to the state I need to be able to measure things. And that's it. So we've initialized everything. Then I mentioned every 2 seconds, I have a .NET process that wakes up and says, give me the lay of the land. So that's just get sensor status. All it does is call this. The rest of the methods here are just commands coming down. So really the beef of what we're doing is get sensor status. And as simple as going through all my GPIO pins, so all the sensors that I've got assigned here, and then doing a read. Okay, check out this pin. So pin 28, which is my son's bedroom window, is it open or is it closed? Get that value, do some mapping here. Change it from low to open, closed, basic .NET stuff, not important to hardware. But read does all the magic. It's as simple as that. With the siren, same thing. I'm just reading. And what I'm saying is the siren on or off? Is that pin high or low, the output pin that I set? And get a value. And then we come down here to the smoke detector. And if you remember, this was the 80-20. The smoke detector was the one that was maybe a little bit more difficult. Code-wise, it actually isn't. All I had to do was take the smoke detector object here. See I'm hovering over it. You can see that it's an INA 219 object, C# object class, and say read current. So it was already initialized above, read current. I get the current, and then I told you my logic was if it's over 30, that was the number I used, this thing's probably siren on. If it's under 30, yeah, probably siren off. And that's it, return them. And then for the turning on the siren and off the siren, they're just writes. You just write the pin low, pin high. Can you believe it's this simple? Or I guess, did you know it was this simple before coming into this talk?
Yeah, that is pretty simple, straightforward.
Yeah, I sure didn't. So it really easy, really excited, and hopefully this gets you amped up and excited to take on your own little project, knowing how simple it is to work with hardware. All right, so for the demo, we've got, so I've got simulated data here, and I've got the three pieces running. So this bottom piece is the sensor monitor, which is this, and it wakes up, what's the status of the world every 2 seconds. In this case, because I'm in debug mode, it's just reading this file, which is all set to closed or open. And what I'll do here, minimize that, come back, and we'll open up a door. Let's open up the back door. So open it up, and you can see 2 seconds. Within 2 seconds, the SignalR has pushed it up. So I can open up there, back door opened up. And now that's been pushed up here. It's in Azure at this point in time, but nothing shows up because we're not in an armed state. But I can go here, current status, okay, door open, then scroll down and back door, click on it, and then see, okay, it was open at this time. So it's a little bit of history, audit history here. Simple enough. A couple other things I can do. So let me close that door real quick. Actually, I'll leave that door open. What I'll do is arm it. So I can arm from the control panel, and you can see I armed it here. It created a SignalR connect. That SignalR connection immediately pushed it here. Well, not immediate, 2 seconds, which is immediate enough for me. Pushed it to SQL Server up in Azure, which is locally running on my machine here, and then pushed it out to the Vue.js application. And you can see here, system is armed, detecting an alarm state. It's red, there's something open, it's armed. Why do you think, okay, looking at this now, why do you think I don't have an alert? Because this is a mobile application. I would typically get a push alert if something is being detected here. Why would you think I don't have one? Think about the use case of where this is, because this was a lesson learned for me. Okay, the control panel is there. Okay, you see it pop up. The control panel is there right by the front door. So naive me said, if I'm in state equals armed and I see something that's causing an alarm state, I'm going to send a push notification. Okay, that's fine. So that's what I coded, deployed it. It's all out there, actually running in Azure, not on my local machine here. And I go to walk out the door and I press armed. 2 seconds later, as I'm almost to the door, because the door is right there, it's pretty close, get my hand down to reach the doorknob to open it, I get a push notification. My phone telling me the system's armed. I'm like, well, yeah, I just armed it. I need to cool down a little bit. So there's a wait period. When you arm it, it doesn't actually send any push notifications until, I think I set it to like 2 or 3 minutes, thinking, okay, that's plenty of time to get out the door, lock it behind me, and now I want push notifications. So just lessons learned. Okay, and let me see. All right, I think, the only other thing, super secret, I can't tell anyone because this is my actual production code, is that if you want to unarm it, you can unarm it from the app. And because you're logged in, I don't show it here, but I actually have a login that is used to authenticate. And I trust, so if you were able to log in, I trust you to be able to push the unarmed status now. If you break into my house, I don't trust you to just go over with your meaty finger and hit armed and disarm it, right? You have trust issues there. So if you come into the house, like most systems, you gotta have a passcode. So 0, 1, 2, 1, unarms it. Again, don't tell anyone, it's a secret. So that's all I have. I think I went a little over 7 o'clock here, but hopefully this was helpful. You got some value out of this. Certainly was. I think I have a little more slide to go through here.
Do you have time for questions?
I have lots of time. Yeah, so just closing thoughts, and then I'll open it up. So you're going to learn a lot. You're going to fail a lot. Linux on Raspberry Pi. If you've not taken on if you can find a Raspberry Pi for a reasonable price, it's ready for prime time. And then the big takeaway here is, hardware aside, use SignalR or consider it. Think of certain use cases for your application where it makes sense, and try to take it into your workplace with client. So definitely would do this again, and extremely happy with the results. Okay, now I'll open it up for questions.
Actually, my question. Oh, sorry.
Well, let me ask real quick. Have you looked at other types of equipment? Like I have a lot of Wise equipment, or not a lot, but some. And so, I mean, could this be done with Wise as far as you know, or are most of the systems open? I guess that's what I'm asking.
No, this is like, I called it, I don't know if I call this level 1, but this is where I got my start in 2020. I mentioned since then, I've got, my whole home is automated. Once you get Home Assistant wired up, so Home Assistant basically controls everything. They have plugins that allow you to connect to things, and they have crafty ways of getting around that. For instance, my garage door opener is really old, from like 2000. I think the home was built in 2011, so it's around that time frame. Obviously not a smart one, but if you go on Amazon, you can buy the Aladdin smart home. You basically just plug it in. It's Wi-Fi enabled. You connect the wires to it, and you use their accompanying app to open and close things. I didn't want to do that. I wanted to automate it. So automate it through Home Assistant. If the product or service supports any sort of API, open API, not an issue. I'd say most probably don't. So how they got around it through Home Assistant, because I didn't write any code for this, it was all built in, is that you have to log in and then, or give them the username and password, and then they just mimic the commands that the application does on the back end. So they probably just put a network sniffer on it, detected the calls it was making to get the token for the authentication, then what it was calling to turn it on and off. And so that's Home Assistant's way of doing it. They built those plugins that either hack the way to make it work or actually use a first-class API if it exists. Wise is, I think, pretty open, but I'm not totally sure, Jim.
Yeah, cool. Thanks. Thanks, Heath.
Yeah.
Yeah, I have a question about SignalR. I've used it a couple times for server to web client, and to hear that you're using it for essentially inter-process communication is kind of cool. And that's supported. I'm just curious if you could give us a short summary of what you're doing there and how you're doing it. Thanks.
Yeah, very supported and very cool. So I'll actually give you an example using a client project. There's a project we're wrapping up. We've had a team there for the last 3 years. And it's working with hardware, interacting with hardware. So we needed to build something that was going to be out on the manufacturing floor, on a wired up to a bunch of devices, and interacting with the hardware. So it needed to be an application. It couldn't be a website of any sort, because it needed to be able to support disconnected states. At the time, back then, our choices were limited. We used WPF because that's what you did, thick client applications in at that point in time. Had I were to do it over again, knowing this was all up and operational, working as good as it does, I would have done something like this, where you build a .NET process that runs in the background, to do all your .NET things and interact with the hardware, and then build a Vue.js application on top of it and use SignalR for the connections back and forth. Having said that, after last year's .NET MAUI Blazor Hybrid release, all bets are off now. So Blazor Hybrid is amazing. I would use that for anything, because you can essentially use web technologies inside of a WPF shell and not even have to touch any XAML code, which for me, some people love XAML. I try to get away from it. So I gave a really long answer. I don't know if that had anything to do with your question.
Well, maybe I didn't quite understand your architecture diagram. It looked, so you had the Pi that just did the really simple, read the state of the world, and then you had the one that's got the controller that runs the Vue web app. Oh, there you go. And wait a second. Oh, right. So it looks like those two Raspberry Pis are communicating via SignalR. And that was a surprise to me, because I've always thought of it as, you've got a web server on one side and a web client on the other. So the web client, so that I always thought that the SignalR client was only JavaScript libraries and the SignalR server side was, .NET. But it kind of looks like you've got it connected so that you can have a .NET client that talks to a .NET server using SignalR.
Yeah, absolutely. Yeah. And so if we think about how this could have been done if we didn't use, let me bring it to this point. If we didn't use SignalR. I could have put just a standard .NET controller in action here and just an API, REST API here. And then from down here, just call REST API every 2 seconds. Nothing wrong with that. It would have worked just fine. Similarly, if I get a command that comes down here, I could have stood up, again, another REST API, call that, and as a command comes in to turn on the siren, no issues. What SignalR gave me was it's extremely lightweight, and it supports bidirectional out of the box. So I didn't even have to write any of this. Well, I had to write methods, but none of the plumbing, none of the HTTP, none of the opening a port up, none of that. I create the SignalR connection up here, which the hub is living up here. Once I have that, it's shown as 2 different arrows here, but it's using the same HTTP WebSocket. So I push down commands from the top. So that was a benefit and why I chose SignalR.
Okay. Yeah, that's definitely something I'm going to look into afterwards. Thanks.
Yeah, and it's everywhere, even out here. That's how, I don't have to refresh anything on the screen. I've got the screen up here. I could have used JavaScript polling to go look for updates, but I don't need to. I got SignalR and I just push it to the Vue.js application and display it. Similarly up here, if I have the application open up, I can just, and I'm looking at something, it changes in real time. I just push the update out across that WebSocket, and then using Vue, just update to state.
So is the transport between, so obviously it's probably using WebSockets on, the Vue.js app. That's sort of classic SignalR, but do you know what transport it's using between, you've got a box labeled SignalR sensor monitor hub and then SignalR connection.
Yeah, it's WebSockets all across. Yeah, everywhere's using a WebSocket connection.
That's really interesting. See that? Yeah, it never occurred to me to use WebSockets server to server. So interesting. Thanks.
Yeah, no problem. Okay. And then here, I'll show you. This is my home assistant. So this is where I am today. There is quite a bit going on here. And then I have my cameras all connected up here. Takes a minute, but you'll see it load up. Okay, other questions? All right.
You don't want to know what you did with the real Heath, the Heath with the hair. Where did he go?
Yeah. It's, who knows? 5 years from now, I may have it back. Maybe green at that point in time. Who knows?
Probably.
Yeah. All right. I appreciate everyone taking time out today to listen to this. Hopefully it was helpful. Find me on LinkedIn, connect. I'd love to talk shop. So any point in time, you reach out to me. I'll talk shop. Happy to. And if you're ever in Columbus, reach out. That's all I got, Sam.
Thanks, Heath. Appreciate it. Yeah, that was a very cool presentation and a very interesting topic. So wanted to thank you again for joining us. Just have a couple of wrap-up announcements before we call it an evening. So if you look over in the chat window, you see that I have a few links that are posted, and we'll cover those in a little more detail right now. And let me go ahead and share my screen. Sorry, give me just 1 second, a little bit of a lag time. All right, so with regards to resources, as far as the presentation itself, obviously it is being recorded and it will be posted on YouTube. If you would please subscribe to the channel to get upload notifications, and the link for that is found over in the chat window. In addition, my blog, I post tech events that are happening, which we'll cover in just a little bit, and you can subscribe to that as well to get updates and notifications. Last but not least, if you would please take a moment to fill out the feedback eval form so we can provide Heath with some constructive criticism. I think it's the least we can do after learning about how to secure your home with IoT devices. Lastly, if you joined us late, special offer from Manning.com on a selection of books, 35% off, and the link for that is also posted in the chat window. with the discount code MTPCLEC21. One of the things that we always like to do is discuss job openings. So you can find job openings available at techsystems.com/IT-jobs. But we always like to ask who's hiring and who's looking. So if you would please make yourself known in the chat window, or jump in verbally if you're hiring or if you're looking for a new place of employment. And while we're waiting on that, I want to share my contact information. Email snasser@NIS Technologies. You can also find me on Twitter @SamNasser. And my blog, once again, samnasser.blogspot.com. And if we're not connected on LinkedIn, I invite you to do so. And with that, let me take one last look at the chat window and see if there's any questions or comments. And it looks like Heath is hiring at CGI, .NET devs, but other roles as well. What experience level are you looking for, Heath?
All over. I'd say not entry level, so probably mid to senior level, all the way up to architect on the Azure and .NET side.
Okay. Excellent. Are these full-time, consulting, remote, in-person?
All the above. All full-time, all with CGI, directly for CGI, and I'd say they're some remote, some hybrid, but for the most part, we're all remote these days.
Okay, very good. Good to know. Excellent. And so with that concludes our meeting. So thank you all for attending. Thanks again to Heath, and look forward to seeing you all next month. Good night, everyone.